To determine whether a sequence is geometric, we have to check whether the ratio a sub n over a sub n minus 1 is a constant, whether it is a constant independent on the value of n. If it is, the sequence is geometric. If that ratio contains the variable n, then the sequence is not geometric. So in our example, we have a sequence with the general term a sub n equal negative 5 to the power n plus 3 over 2 to the power n. If we want to look at the ratio a sub n to a sub n minus 1, that I will have to find first formula for the term a with the index n minus 1. It means that I will use the formula for a sub n and replace every n in that formula with n minus 1. So we have n minus 1, then we add to that 3, and we divide by 2, and instead of n, we'll enter n minus 1. After simplifying, on the top we'll have negative 5 to the power n plus 2, and on the bottom we'll have 2 to the power n minus 1. Now we are ready to look at the ratio. So a sub n is a fraction, negative 5 to the power n plus 3 over 2 to the power n. And a sub n minus 1 is also a fraction. Numerator is negative 5 to the power n plus 2. And the denominator is 2 to the power n minus 1. So this ratio is the quotient of two fractions. So to divide two fractions, we take the first fraction in the numerator, and we multiply this by the reciprocal of the fraction in the denominator. So we'll multiply it by 2 to the power n minus 1 over 5 to the power, or negative 5 to the power n plus 2. Notice that in numerator and the denominator we have powers of negative 5 as well as powers of 2. So what we'll use is the property of the exponents that says that if we are dividing two exponents with the same base, then we'll keep the base and subtract the exponents. So if we combine the 5's, or negative 5's rather, we'll get negative 5 to the power exponent on the top n plus 3 minus exponent on the bottom, which is n plus 2. We'll use the parentheses because we are subtracting two terms. And if we do the same for the powers of 2, we'll get 2 to the power, on the top we have n minus 1, and on the bottom we'll have n. If we simplify those exponents, we'll have negative 5, and the power in the numerator is going to be 1. And then we'll have times 2, and the power of 2 will be negative 1, which we can rewrite as negative 5 over 2. This is a constant. Notice there is no n in this expression. This is a constant. No matter what value of n we choose, we'll get the ratio always equal negative 5 over 2. And therefore, this sequence is geometric because the condition of the definition is satisfied. The ratio of two consecutive terms is constant. A sub n over a sub n minus 1 is negative 5 over 2.